Angles in the interior of a circle are angles where the vertex Angles in the interior of a circle are angles where the vertex is inside of the circle. Angles in the interior of a circle are angles where the vertex is inside the circle. And that's what interior really means. Interior means inside. So, as we look at our diagram, we see these two chords that intersect each other, creating two angles. And since these two angles are vertical angles, we know that they are congruent. These two angles are congruent, and let's switch on our flashlight. They actually create two arcs, one going up and one going down. Now those two arcs will not always be congruent, depending on whether the vertex is further down, then the lower arc would probably get larger and the upper one would get smaller, and the other way around. So, but those arcs don't necessarily have to be congruent, and the formula to find one of these angles based on the arcs is 1/2 of one arc plus the other arc. So it is, in a way, the average of those two arcs. Again, another formula for us to highlight, to really be aware about and remember from this lesson. So going back to our diagram, what this would mean is the measurement of angle 1 is equal to 1/2 the measurement of arc AC plus the measurement of arc BD. So let's look at some examples. And again, we have to find the value of the variable. Let's switch on our flashlight. Here we have our angle X, and it creates the intercepted arc MQ on the left and the intercepted arc NP on the right. We have the measurement of both of these arcs, and our formula says the measurement of the angle is equal to 1/2 the measurement of one arc plus the measurement of the other arc. X is equal to 1/2 times 110 plus 30. That means X is equal to 1/2 times 140, or X is equal to 70 degrees. That's the measurement of our angle. And on to example 15. Our flashlight shows us that our angle that's measuring 45 degrees creates this arc and that arc, and both arcs are given only with an expression and a variable, but we know what the angle is. The angle is 45 degrees, and 45 is equal to 1/2 of 2x plus x. 45 is equal to 1/2 times 3x. Let's get rid of our fraction by multiplying by 2 on both sides. 90 is equal to 3x, and as we divide by 3, we realize that x is equal to 30 degrees. And last but not least, angles in the exterior. And if angles in the interior are angles where the vertex is inside of the circle, angles in the exterior are angles where the vertex is outside the circle, of course, right? Exterior means outside. Let's look at our flashlight again. So if the angle is on the outside, then what happens is we also create two arcs, and of those two arcs, one, the closer one, is always the smaller arc, and the one that's further away is always the bigger arc. And therefore our formula goes like this. The measurement of the arc is equal to 1/2 the measurement of the big arc, and this time minus the measurement of the small arc. For our picture here, that would mean that the measurement of angle 1 is equal to 1/2 the measurement of arc BC minus the measurement of arc AC. So this is the last one of our formulas about angles and arcs. And again, be sure to highlight that and memorize it. We need it for this lesson. Let's look at our last set of examples. Find the value of the variables, and we already have our flashlight on. So this angle X creates two arcs where the measurements are given. So X is equal to 1/2 the measurement of the big arc, which is 138, minus the measurement of the small arc, that's 66. So X is equal to 1/2 times 72, and that means X has a measurement of 36 degrees. In our next example, the arcs created by our exterior angle are pretty large, as our flashlight shows us. One of the arcs is given at 260 degrees. We don't know the measurement of the other arc, but as we can see, both arcs together make up the entire circle. So that's the entire 360 degrees. That means that our smaller arc has to be 360 minus 260, and that is 100 degrees. Okay, that means we're good to go now. X has to be equal to 1/2 times the larger one, 260, minus the smaller one, 100. X is equal to 1/2 times 160. That means X is equal to 80 degrees. And on to our last example for the day. Switching on our flashlight. Again, this angle also creates two arcs that together make up the entire circle. Only this time we're given the angle and we're given expressions that describe the measurements of the two arcs. Let's write down our formula one more time just to make sure that we're plugging everything in the right place. The measurement of the angle is equal to 1/2 of the big arc minus the small arc. That means 61 is equal to 1/2 of 10x plus 1 minus 5x minus 1. Let's clean up inside of our parentheses. 10x minus 5x is 5x, and 1 minus -1 means 1 plus 1, so that is 2. Okay, next we want to get rid of our fraction. Multiply both sides by 2. That means 122 is equal to 5x plus 2. Subtract 2 from both sides. 120 is equal to 5x. And last, we're going to divide by 5. And that means x is equal to 24 degrees. Okay, you guys, we covered a lot of ground in this lesson. So the last thing I want you to do for today is just look back and write down in your summary section the 4 formulas for the different types of angles. Central angles, inscribed angles, interior angles, and exterior angles, to have them right next to each other. That'll help you remember them better. And I will see you in class.